Critical numbers. In this video, we will calculate the critical numbers of the function. Let's start with the definition of the critical number. A critical number of a function f is a number c in the domain, that's important, of the function, such that either derivative at the point c is 0 or derivative at the point c does not exist. If the derivative is 0, we know that at that point tangent line is a horizontal. Because derivative exists is 0, we have horizontal tangent, and these points are important points. Of course, we call critical numbers. Some extreme values are happening, local maxima, local minima, but in this video we will just calculate, we will just find out these numbers. And as we can see, that's the number c sub 1, c sub 2, c sub 3. Because to start looking at some extreme values and later some optimization problems, we have to identify these numbers. Okay? That means this is the case if the derivative is 0. We may also have a lowest point or locally lowest point or locally highest point at the situation that derivative is undefined. At that corner, derivative is undefined. Yeah? Derivative at c does not exist, DNE. Okay, that's also important point, critical number, critical point. We have to identify this, and we can state the other theorem. It's called Fermat's theorem. If function has local maxima, local minima at c, then c is a critical number, always. However, the converse of this theorem, it's false. It's not always true, it's false. If function has a critical number, then always local maxima or minima are happening at these points. No, that's not true, because we may get a nice, easy function, for instance, x cubed. We know how function x cubed looks like this. Yeah? And at 0, derivative is 0, because derivative of this function, it's 3x squared, and derivative is 0 if 3x squared equals to 0, 3x squared equals to 0 if x is 0. That means we can see quite quick process. We found this is a critical number, and x, of course, 0 is in the domain, because domain for polynomials are all of the real numbers, and derivative is always defined. That's, we don't even have to consider that case. But we can see this is critical number. However, no extreme values occurs at that point. And that means this is critical point. Tangent is horizontal. However, function doesn't attain like locally highest, locally lowest point, or absolutely highest or lowest point. That's the types of extreme values. Yeah? So not all of the critical numbers are giving us extreme values, but still, this is a critical number. It's an important number. If we would like to draw a horizontal tangent, that will be the point. And that means it's still a critical number, but not, we have to just make sure that we know that not all of the critical values will give us extreme values. Okay, but as mentioned, this video, we will practice just finding the critical numbers. And yeah, let's start. Exercise number 1. Find the critical numbers of the function f of x equals to x times x plus 1 cube times, I just stress this out because we will use the product rule to find the derivative. If I will expand this, avoid the product, then I will have the polynomial, 4th degree, and as mentioned before, domain for the polynomials are all of the real numbers. Yeah, all real numbers. Then whatever number we will find, it will belong to the domain, and if we satisfy the condition, it it will be the critical point. Also, for the polynomials, derivative is defined everywhere because polynomials are the nice and smooth curves like this. No jumps, no asymptotes, no sharp corners. Let's start the work. For the critical numbers, we will always start with the derivative. Let's find out what derivative is. Product rule. Derivative of x is 1 times the second function plus x times derivative of the second function. Derivative of x plus 1 cubed is 3 times x plus 1 squared and times derivative of the inner function, which is 1. Okay, we have x plus 1 cubed plus 3x, x plus 1 squared. We have two terms, and that's the two terms, and the common factor is x plus 1 squared. We can factor out. It will the first underline the blue quantity. If we take out x plus 1 squared, x plus 1 will stay. And we took from the second quantity, we took x plus 1 squared, 3x will stay. Because the factored form is a good form to find the critical points. And then we have x plus 1 plus 3x, 4x plus 1. Excellent. And as mentioned before, derivative is 0. Derivative is always defined. That means in this case, derivative f prime of x is undefined. Yeah? We will not look at this case because derivative is always defined. But derivative is 0 at some point, and we have to find these points, and that's the critical points, critical numbers. Okay, derivative is 0 if x plus 1 squared times 4x plus 1 equals to 0. Okay, now we have a product form. We can use 0 product property, x squared plus 1 equals to 0, or 4x plus 1 equals to 0 for the product above to be 0. Okay, x plus 1 squared equals to 0 if x equals to -1. And this belongs to the domain. That means this is a critical point. Or 4x plus 1 equals to 0 if x equals to -1/4. This belongs to the domain, and this is a critical point. That's critical numbers, -1 and -1/4. Exercise number 2. Find the critical numbers of the function cube root of x. We may know the graph of cube root of x and know the number right away, but let's start with the derivative. Cube root, it's not a polynomial. That means we have to be careful with the domain. However, cube root can take any numbers. Yes, x could be any real number, positive or negative. I mean, any real number, that's the domain. Okay, let's start with the derivative. Derivative of the function x to the power of 1/3. 1/3 x to the power of -2/3. 1, 3. Let's rewrite without the negative exponent. -2/3, we will move x to the denominator, and we're losing that negative exponent. And let's rewrite this as a cube root of x squared. Then it's a little bit clearer. Okay, and now what we have to consider two cases for the critical points. I can maybe write here. Derivative is 0 or derivative is undefined. We have to find these x's. Derivative looks like this. 1/3 cube root of x squared equals to 0 if fraction equals to 0 if the numerator equals to 0. But when we do this, the numerator doesn't depend on x. That means this is never true, which I can even say no solution. Yeah? We can say no solution, no x that will give this fraction to be 0. This is never 0. Now, derivative is undefined if 1 over 3 cube root of x squared is undefined. Let's do this way. Fraction is undefined if denominator equals to 0. Yeah, we know this from algebra. Denominators equals to 0 if x equals to 0. Perfect. X belongs to the domain. This is a critical number. Critical number. That's the only number that is we've got from this calculation. One more time, please remember the condition for the critical numbers. And as I mentioned, we supposed to know the graph of cube root of x is the inverse function of x cubed. So we can just, oh, okay, looks good. Cube root of x. And we remember the beginning of this video, I gave function x cubed as an example of the critical number x equals to 0 and not giving us extreme values at that point. But what was interesting, at 0, I can even come back, at 0, x cubed had horizontal tangent. Now, cube root of x is the inverse. Then at 0, we have a vertical tangent. Yeah, that's another like way. And vertical tangent, the vertical lines, the slope is undefined. Slope is undefined, then we have no derivatives at that point. Yeah, we can say no derivative at 0, dne, and that's the 0. That's what we've got. Derivative is undefined. Everything makes sense. I hope you will practice. Yeah. You may pause the video before you seeing the solution and do your work on your own. Okay, exercise number 3. Another root function, square root of 1 minus x squared. We may also know how this looks like, right? You probably think, no, I don't know the graph. Okay, let me show you something. When I will rewrite this function like this, and when I will square both sides, and when I will add x squared to the both sides, now we recognize the equation x squared plus y squared equals to 1. It's actually a circle, right? It's a circle with the center 0, 0 and radius 1. Yeah? But now, when we will try to solve this equation for y, then I will reverse the process. I will subtract x squared from both sides, and we will take the square root. Taking the square root, we will have plus or minus. Yeah, that's the algebra. And since we have only positive square root, our equation is just half of the circle, the upper one, the positive one, because we only have positive. Okay, just a little bit of algebra on the side. And we can see critical point. -1 and 1, we probably will get this because the derivative is undefined at the endpoints. That's mean -1 and 1 will be a critical point. And we also notice horizontal tangent at 0. It's mean -1, 0, and 1. That's critical numbers, but let's do the work. Let's get these numbers explicitly. How I will start? Seeing the square root domain. Quantity under the square root must be positive because the square root is taking only positive numbers. It means quantity 1 minus x squared must be positive or could be 0 also, greater than or equal to 0. And we have to solve this. This is quadratic inequality. We will factor out. Okay, and then we can look at the zeros. The zeros are -1 and 1, and we can analyze this intervals for the sign. When we will put the test value, like for instance, -2, and substitute here, then we will know the sign. 1 minus -2 is positive. 1 plus -2 is negative. Negative times positive is negative. Let's take the test value 0. 1 minus 0, 1 plus 0, of course, is 1 times 1, positive. And then let's take 2. 1 minus 2 will be negative. 1 plus 2 will be positive. Negative times positive, negative. And we're looking for positive greater than or equals to 0. We're accepting endpoints and only that interval. I mean, our function, domain for this function is x belongs to interval from -1 to +1. Of course, you can see the graph from -1 to 1, yeah? But we got this algebraic. That's the domain. Only numbers from that interval will work. If something is outside, we not accept it. Okay, derivative. Let's find the derivative. What we can do, we can rewrite this as a quantity to the power of 1/2. Okay, 1 minus x squared, that quantity to the power of 1/2, derivative. 1/2, 1 minus x squared to the -1/2, and times -2x as a derivative of the inner function. Okay, let's make it easier. 1/2 times -2x, 2's are cancel out, negative x will stay. Negative x, 1 minus x squared to the -1/2. Let's make this. Negative x will be on the top. Negative exponent is telling us to take the quantity in the denominator, to flip the number, and 1/2 is the square root. Okay, perfect form. And now, derivative is 0 if that fraction is 0 if the numerator is 0. Okay, and numerator is 0 if x is 0. Perfect. Or the second condition for the critical numbers, derivative is undefined if this fraction is undefined. Fraction is undefined if the denominator is 0. Denominator is 0 if this quantity is 0 and this quantity is 0 if x is plus or minus 1. That's what we were expecting, plus or minus 1. Both, all of the numbers, this belongs to the domain, this belongs to the domain. They are critical numbers, positive and -1 and 0. And as I mentioned, we're just looking for the critical numbers. We will not analyze. We have the graph. That's we see -1, 1 endpoints, no extreme values. Actually, maybe the absolute extreme values. And at 1, I mean at 0, we have horizontal tangent. And makes sense. Derivative is 0. This is condition, and that's the second condition. Okay, exercise number 4. Cube root. Cube root will take all of the numbers. Yeah? And this one, we will maybe not focus on the graph because we may try to get the graph, but this one is not a standard, not the common graph. Let's just find the critical numbers explicitly. Cube root can take all of the numbers, then we go with the domain. All of the numbers are good. Let's find out the derivative. What we can do? Derivative. I can use this power form. Okay, derivative of quantity x squared minus 2x to the power of 1/3. 1/3 quantity x squared minus 2x to the power of -2/3 and times 2x minus 2. Yeah, because derivative of the inner function. let's make it the form without the negative exponent. 3 will go in the denominator, 2x minus 2 will stay on the top, and quantity x squared minus 2x, because of the negative exponent, will go down, and this is cube root of the quantity squared. Perfect form, nice, compact. Okay, critical numbers. Derivative of x equals to 0, and we have to find out, or derivative is undefined, and we have to find out where. That's the condition. Derivative is 0 if this fraction is 0. This fraction is 0 if the numerator is 0. 2x minus 2 equals to 0, x equals to 1. This belongs to the domain, that's the critical point. Undefined. Derivative is undefined if this fraction is undefined. This fraction is undefined if the denominator is undefined. Denominator is undefined if this quantity is 0. Because we don't, 3 is never 0, cube root, that quantity must be 0. Then the entire denominator is 0. Okay, let's factor out x. And then we're getting 0, 0 product property, or we're getting 2. This belongs to the domain, and this x equals to 2 belong. All of the numbers are in the domain. All of these numbers, 0, 1, and 2, are the critical numbers. And then we can do next level. We can jump to the next level and analyze the extreme values, local, maybe the absolute values, but this is just the exercise to finding out these points. Yeah? And please make sure that we're confident with this. Okay, next one. Funny function, x to the power of 1/3 minus x to the power of negative 2/3. This rational exponents, 1/3, 2/3, negative 2/3, they indicating cube root. And that means this is cube root of x, this is cube root of x squared, but in the denominator. If I will rewrite this function, I will write cube root of x minus cube root of x squared. So that form is showing me right away that x equals to 0 is not in the domain. Cube root can take all of the numbers. That means we not worry for the negative numbers to be excluded. No, that's only for the even root. But 0 is definitely not in the domain. It means x is not 0. If we would like to state nicely the domain using the interval notation from negative infinity to 0 and from 0 to positive infinity. Okay. We don't know the graph. We don't even want to think at the moment about the graph, because our point is just to find out critical points. Let's find the derivative. Okay, x to the power of 1/3 is 1/3 x to the power of negative 2/3 minus x to the power of negative 2/3 will be negative and negative 2/3, positive 2/3, and x to the power of negative 5/3. Yes, I am right. I'm just double checking. 5/3. Okay. We really need to get one single fraction. We have to. What we can do, we have a couple of algebra ways to find this, but I will try to factor out the common factor. Right? That's, we have two terms, similar like we did the first. We have one term at the second term. And what I see definitely 1/3, the common factor, and I see x to the power of negative 5/3, the lower number. And then what stays? This one will be actually not 2/3. The second quantity is easier, it's just 2. Because this x to the negative 5/3 is taken outside, 1/3 is taken outside, only 2 stays. Now, the first quantity. 1/3 is outside, okay, but x to the negative 2/3 was the original exponent, and I took away x to the negative 5/3. This means what will be the new exponent? When we multiplying, right, like x to the negative 5/3 and this one, when we multiplying the same base, we may add the exponents. And the original exponent was negative 2/3. It means now negative 5/3 plus what number? Because we're adding the exponent to get negative 2/3. Yeah, that will be that box. I think it's 1, right? It is 1 because 1 is 3/3. 3 minus 5 is negative 2/3. That means this will be 1. X to the power of 1. Yeah, nice. Okay. A little bit of algebra. Always. Okay. Then what we have? This will be 1/3 cube root of x to the power of 5 in the denominator, and this is just x plus 2. I may rewrite one more time, and we do have nice single fraction, x plus 2 on the top, and cube root of x to the power of 5 in the denominator. And we may see the critical numbers right away. Derivative 0 if x equals to negative 2. Derivative undefined if x equals to 0. Done. Yeah, let's write it down. Condition for the critical numbers. We have to find out where derivative is 0 and where derivative is undefined, DNE. Derivative is 0 if this fraction is 0. This fraction is 0 if the numerator is 0, always. Negative 2. And belongs to the domain. Perfect. Okay. Now, I have one correction. Derivative is undefined if this fraction is undefined. This fraction is undefined if the denominator is 0. Of course, denominator is 0 if x is 0. Oh, I think my statement was a little bit incorrect. This number is not in the domain. Okay, we can see we will not accept. We did our work and we have to do it, but that's not a critical number. The only critical number only, it's negative 2. Critical number, it's x equals to negative 2 only. Okay, please be careful. We can see it's so easy, and I even did it. It's so easy when we did the nice job with the derivative. We have the nice fraction. We see the zeros on the top, the zeros on the bottom, but this is not in the domain. Okay, that means it's worth to do all of the steps. Okay, only negative 2. Good. Another one. Oh no, another. Fractions. I mean fractions in the exponent, rational exponents. Okay, x to the power of 3/4 minus 2x to the power of 1/4. Okay, yeah, you may pause the video and try to do it because it's extremely similar to the exercise number 5 with respect to the algebra. The only thing is now we see 3/4, 1/4. We see the even root. Yeah, because if I will rewrite this, this will be 4th root of x cubed, and this is just 4th root of x. Even roots are not taking negative numbers. That means the quantity x cubed and x must be positive. They are positive if x is positive. That means this is the domain, and actually equals to 0, because that's not the denominators. Domain is, let's say, oh no, that was good. X belongs to that interval only. Okay, just the positive numbers, including 0. Okay, let's find out derivative. Okay, 3/4 x to the power of negative 1/4 minus 2 times derivative of x to the 1/4 will be 1/4 x to the power of negative 3/4. Okay, and let's do the same. Let's factor out the common factor. Okay, no, I can keep this. We may simplify, but I will not simplify because I will say 1/4 is a common factor and x to the power of lower number, -3/4. And then what stays? This one is again, I took away the entire factor, then 2 stays. Looking at the first quantity, I took only 1/3, then 3 stays. And the same algebra exercise. -3/4 plus what number to get -1/4? I think it's again 1, right? 1 minus 3/4 is, oh, no, not at all. You see my assumption. I think it's positive 1/2, correct? Because 1/2 -3/4 plus 1/2, because we will be adding. If we multiplying this, we're adding this and getting, that's the result from this addition, because x and x the same base. -3/4 plus 1/2, which is 2/4, will give us -1/4. Okay, a little bit different, because usually is nice number 1, but 1/2 we can also take it. Okay, let's rewrite as a fraction. 4 will go -3/4, 4 root of x cubed, and 3 x to the power of 1/2 is the square root of x. I can rewrite like that. Let's make it smaller. Okay, this is our derivative. And we almost see the zeros from the denominator and numerator. Okay, but let's do it, the condition. Derivative is 0, we have to find out where, and that's the critical point, or derivative is undefined. Condition for the critical numbers. Derivative is 0 if this fraction is 0. This fraction is 0 if the numerator is 0. Okay, 3, 2, square root of x equals to 2/3. Squaring both sides, we will get 4/9. 4/, square root of 4/9 is 2/3. 4/9 is a positive number. Yes, this is a critical number. It belongs to the domain. Okay, undefined. Derivative is undefined if this fraction is undefined. This fraction is undefined if the numerator is undefined. Denominator is 0. If the denominator is 0, then that's derivative is undefined. Denominator is 0 if x is 0, and x0 actually this time belongs to the domain. 0 and 4/9. That's the critical numbers. And we will of course stop here. We will not analyze further. Later, we will take these numbers and do different things. But we have to know how to find out critical numbers. Okay, another one. So, critical numbers of the function 1/x times x minus 4. Nicely, we can see x cannot be 0, x cannot be 4. If we like the interval notation, x belongs to from -∞ to 0, from 0 to 4, and from 4 to +∞, with just excluding 0 and 4. If we get 0 or 4, then we're not accepting. Okay, what we can do? How we can find out derivative, because we need the derivative. Shall we use the quotient rule? Whatever is easier. I can possibly do this. It's not no, no, let's actually do it, because we will still get back to the factored form. I'm just trying to find out the way for the easiest derivative. You may do your own way. It's still fine. You may use the quotient rule, keep the product, but then we have products in the denominator. But I will distribute x squared minus 4x and everything to the -1. What do you think? Yeah, I think it's good. That's the same thing, but that form will be easier for the derivative. Okay, derivative of the quantity x squared minus 4x to the -1 is -1 quantity x squared minus 4x to the -2 and times derivative of the inner function 2x minus 4. Okay, not bad. Let's rewrite nicely. -1 and quantity 2x minus 4 will stay on the top, and quantity x squared minus 4x will be taken to the power of 2 in the denominator. Perfect. We cannot really simplify. We have a fraction. That's what we need always for this different functions than polynomials. And we almost see the zeros of the numerator and denominator. We know what this means, but let's do it nicely. Okay, I can maybe do here. Derivative is 0 if numerator is 0. Yes, the fraction is 0 if the numerator is 0. Okay, then x, let me speed up. X is 2 actually. 2 times 2, 4, 4 minus 4, 0. And 2 is good. 2 is good, belongs to the domain. 2 is a critical number. Check. Now let's do this. Derivative is undefined if this fraction is undefined. Fraction is undefined if the denominator is 0. X squared minus 4x. Yeah, x squared equals to 0. This is 0 if just the quantity inside is 0, and we can factor out. And we may see 0 and 4. And that's actually funny. Derivative is undefined at 0 and 4, but 0 is not in the domain and 4 is not in the domain. Okay, that means only 2 is a critical number. They are not critical numbers. Yeah, please. Probably we will have asymptotes or some discontinuity. We don't know. We have to figure out later. But they are definitely not the critical numbers because they are not in the domain. Yeah, please always check against the domain. Only 2 is a critical number. Okay, another one. I have 3 more, and we will be done. Lots of practice for you. Okay, find the critical number of the function x times e to the x. Exponential, e to the x takes all of the numbers. Domain are all of the real numbers. We are good here. Let's find out derivative, product rule. Derivative of x1 times e to the x times derivative of e to the x, e to the x. So nice. Let's factor out e to the x, 1 plus x. And now derivative is 0 if e to the x times 1 plus x equals to 0. And we may notice, but let's put this, derivative is undefined if e to the x times 1 plus x is undefined. But yeah, let's start with this. This expression is always defined. Yeah, we have no denominators, like no 0. E to the x is defined for any numbers. That we have no solution. No solutions, because domain is all of the numbers, but it's still no, it's still not a case, because sometimes we have domain all of the numbers, and we may have a points like with the sharp corners. But this one is this expression. Yeah, it's the combination of the linear function times exponential. It's always defined. That's we have no solution. But this one, this expression, this factored form is 0 if e to the x is 0, or 1 plus x is 0, one of the factor. 1 plus x equals to 0 if x equals to -1, and this belongs to the domain. This is definitely a critical number, check. But e to the x is never 0. E to the x, e to the power of any number is always a non-zero number, and it's actually always positive. No solution from this. So only -1. Yeah, only -1. You may use maybe Desmos to find out the graph. Yeah, but -1 is a critical number only. What is happening at -1? We still don't know. Okay, exercise number 9. Oh no, trigonometric. Yeah, let's try. 2 cosine of x plus sine square of x. The only thing is, let's probably, when we will have this question with respect to the domain is all of the numbers, but we know that trigonometric functions are periodic functions. So let's make some restriction and let's find out the critical points only between 0 and 2 pi. Okay? Because then we will repeat these numbers. Every 2 pi, the scenario, the situation repeats. Okay, let's find out the derivative. Maybe I can write here. Derivative of 2 cosine of x is -2 sine of x. Now, sine of square x, sine of x squared, derivative of the quantity squared. Yeah, that means sine square of x will be 2 times sine of x times derivative of sine, derivative of the inner function, cosine of x. Okay, we need a product form. I will factor out just sine of x. -2, actually I can also factor 2, but I would like to keep the negative inside. -1 will stay, plus cosine. Let's rewrite one more time. 2 times sine of x and cosine of x minus 1. If we have 2 quantities, if one is negative, one positive, it's easier to put the negative as a second one. Yeah, just to reverse, because then we not miss that negative. Okay, nice product form. And we may also notice this derivative will be defined everywhere. This is nice and smooth function, but we will have points where derivative is 0. I mean, derivative is 0 if 2 sine of x cosine of x minus 1 equals to 0. Derivative is 0 if this is 0. Product form. 2 sine of x times cosine x minus 1 is 0 if 0 product property. This is 0 or this is 0. Sine of x equals to 0. Sine for what angle equals to 0? 0, pi, 2 pi. We know that. Now let's look at cosine of x equals to 1. For what angle cosine of x equals to 1? For 0 and 2 pi. Am I right? I think so. That we can see 0 pi and 2 pi are the critical numbers, because we actually overlap, we repeat them. So we can say critical numbers are x equals to 0, pi and 2 pi, because 0 and 2 pi is repeated. Okay, and all of them are in the domain. 0 and 2 pi are the endpoints, but still they are important numbers, because at the endpoints, yeah, we don't know what's happening. We have to, yes, we don't, let's just find the critical numbers. We did find the critical numbers, they are in the domain, and I don't want to analyze if we have local maxima, minima. We will do this later. We have to know how to find the critical numbers, and let's finish this exercise, the set of our exercise with question number 10. Oh, it's multiple choice. Looks like a maybe quiz question, quiz type question, exam type question. Okay, our function is x times 1 minus x to the power of 1/5. Okay, 1/5, we have a definitely product, but I can maybe rewrite like this. This is the fifth root. The odd root can take any numbers. So actually domain is all of the numbers. If we will have some restriction with the domain, we may look at the numbers and eliminate them, but not in this case. Domain is all of the real numbers. That we're not eliminating an option. Every option could be the correct. Let's find out the derivative. That's of course the point. That's always. Okay, x times product rule. Derivative of x is 1 times the quantity 1 minus x to the power of 1/5 plus x. Derivative of 1 minus x to the power of negative, to the positive 1/5. 1/5 times 1 minus x to the power of negative 4/5 minus 1, and times negative 1, derivative of the inner function. Okay, let's rewrite like this. Negative number and x over 5 will be here. Okay, and we have the same situation. We will factor out a common factor. Looking at this quantity and this. The common factor is quantity 1 minus x to the power of lower number, negative 4/5. And what will stay? This second quantity, x over 5, will stay. Perfect. But for the first quantity, 1 minus x to the power of 1, because 1 plus negative 1/4 is positive 1/5. When we multiplying back, if we will decide to distribute back, we will multiply the same base, then we adding the exponents. A little bit of algebra. Now what we have? Let's rewrite. This one is fifth root of the quantity 1 minus x to the power of 4. And this will be x, no, 1 minus x, because to the power of 1, I can ignore. 1 minus x minus 1/5 x. No, am I taking too much space? But we will see the zeros right away. Fifth root of this quantity, and this will be 1 minus 6 over 5x. Makes sense, because negative 1 and negative 1/5 will give us negative. Okay, derivative is 0. What we can do, let's do this. Let's here. Derivative is 0 if the numerator is 0. 1 minus 6 over 5x equals to 0. Then x equals to, we will subtract and multiply, subtract 1, this will be negative 1, and multiply by 5 over 6. 5 over 6, that belongs to the domain, all of the numbers. That's the critical number. The derivative is 0 if this is 0, or derivative is undefined if this fraction is undefined. This fraction is undefined if the denominator is 0. Denominator is 0 if x minus 1 is 0. X equals to 1. And 1 is also in the domain. Perfect, 1. This, no. No. This is the option, am I right? See, we have to be careful. 5 over 6 and 1. That's the critical numbers. Okay. I hope this set of exercise will really give you a confidence with finding the critical numbers. Thank you.